We're back again with another video. Nevertheless, let's get into. We got int of f prime x divided by ax plus n dx equal to 1 over a ln the absolute value of ax plus n plus the constant c. Okay guys, let's have some examples. We got int of 2 divided by 2x plus 3 dx equal to, let's check this out. This one, guys, is in this form: f prime x divided by ax plus n, where the denominator is the derivative of this term ax. So here we have a as the coefficient of x. Okay, let's check this one. Here on the denominator we got 2x, meaning that the value of a is 2 and the derivative of this one will just give us 2. So we can write it in this form: 1 over a. In our case a is 2, it will be 1 over 2 ln 2x plus the value of n is 3. So the answer to this will be 1 over 2, because the value of a is 2 ln the absolute value of 2x plus 3, because we have ax plus n. So we're gonna get 2x plus 3, the absolute value, plus the constant c. Okay guys, let's have one more example. For the sake of practice, let's do this one. Here we have x divided by x squared plus 1. However, we know that the numerator must be the derivative of this term. And here we have x to the power 2, meaning that the derivative of x to the power 2 will give us 2x. So here we're supposed to have 2x, not x. To make it to be 2x, we have to do it like this: 2 divided by 2. 2 divided by 2 is 1. So we got integral of x divided by x squared plus 1 dx, which can be written as, because we want to make the numerator to be 2x, so we're gonna take this 2 and place it here. Then we will be left with 1 over 2, the integral of 2x divided by x squared plus 1 dx equal to, now we can write it in this form, since the derivative, this derivative 2x, the derivative of x squared is 2x. However, don't forget that we have 1 over 2, so we're gonna get 1 over 2 and the integral of this will give us 1 over a. In our case, a is nothing but 1, so we're gonna get times 1 times 1 over the value of a is 1 ln the absolute value of x squared plus 1 x squared plus 1 plus the constant c.